Right, welcome back to the channel. Something very different this way comes today. We have the Sears AM Walkie Talkies, which were sent to me for repair by Dom. This is one of two that were sent through, and I think there were transmit or receive problems on either one or both. I can't remember now, but we're going to use the Tiny SA today, which we're going to use as our signal generator and also our spectrum analyzer to have a look at these to see how what the problems are with them. I haven't got a circuit diagram for them. I'm not sure. They probably did appear under a different name, under a different brand. They're quite an old set, these. I think they were 1977, it says there on the back there, July. So that was a very long time ago. So we might have some tired old capacitors in here. Let's see if we can get some power onto it first and see what it is and isn't doing. It looks like we do have a note. I'm just having a look. We've got all of the crystals on the board. You can see there that they've not been removed, which is good. We've got all three crystals on the board, and we've got our 9-volt battery compartment. Now this is a genuine 9-volt. It says there, standard 9-volt. Underneath the flap is the speaker. Okay, nothing more. So let's just see what the little note says from Dom. It says frequency 1, 27125. Frequency 2, 270850, frequency 3, 270150. So channel 14, 11 and 5. Transmit, no TX audio or receive audio. Okay, well I'll trust Dom is right on that, but we will test that first. So let's, what we do for this actually initially is it's easier to get the Randy in. Expensive radio, the Randy, so I do like to use it all the time. So let's bring the Randy in and check this out. Okay, right, we've got it on channel 14, which is F1, our first position. We've got the aerial fully extended, and we've got a nice solid carrier there, but we definitely not got any transmitted audio. But what we do have is a call. If you watch this, so the call is definitely working, but we're definitely not getting any modulation on there at all. So that's interesting. I don't think that'll be anything too much then. We should certainly probably be able to sort that, I would think. Let's just check the other channels while we're here. So we go to F2, which according to the list here is channel 11. And there we go. Just get the shade over that. Again, we've got no TX audio as you would expect. And if we go to channel 5, we'll try again on here. Go to number 3, which should be channel 5. Get a little beep, don't we? We get the tone, but we're not getting, and he says we're not getting any received audio on this either, so we'll try that. No, so we're transmitting on the Randy here, albeit we're in low power, but we're right next to it, so we should be getting something. There's not even breaking the speaker there, so that's something. We've got an earphone socket on there. But I would imagine this is probably, considering the age of these, this is probably going to be capacitors, I would think. Possibly, I'm not sure. Let's just check the what Dom says for the other one. What I'm going to do is put a sticker on this one. This is radio A, and we'll call the other one radio B. Okay, we've now opened radio B, and let's see what Dom says for this one. Seems all okay. And we've got the same, obviously the same channels there, which you would figure would be right. So let's pop a 9-volt battery into radio B and see what this one is doing. Just double check that this is okay. But that's great. We've got one radio we can work from, so we can take references from this one to get the other one going. Okay, so this is radio B then, the apparently working one. We've switched it on. We're not getting any hiss, but let's just try transmitting on this one. So we're on the 3rd channel, and it looks like we're getting a tone on here. That could just be feedback. Let's just turn. No, there is a tone on transmit. Ah, the call is on, that's why. Okay, so we are getting TX there, and we are getting TX audio. That's good. So TX audio is good. So let's go up to number 2, which is channel 11. And that's good. And then we'll go up to 14 channel 1. There we go. And we'll just, we can hear the feedback there. I'll just move it away. Try it over here. 1, 2 testing. Yes, it sounds a little bit off frequency there, but that does appear to be working okay. And the call, again, I think that's because it's off frequency. They're both transmitting, but this one is off frequency, I think, compared to the other one anyway. So okay, let's go back to the other one, and we'll get that one apart and just see if we can see why it's doing that and see why we're not getting any audio from it. Okay, so radio A. As we're having a good look at it, you can see the side profile there. Very typical of its time construction wise. Pretty decent for a 9-volt set, really. Very simple pared down set. Like I say, the main issue with this, I would think, is the capacitors. I'll see if I can trace back on the circuit diagram the capacitors leading to and from the speaker. It might simply be the speaker audio here is an issue, so that the speaker's either open circuit or something. It's a decoupling capacitor connected to that speaker or some kind, or is causing a problem there. So it might be something as simple as the speaker. So we'll start off with the speaker, because with these sets the speaker is both the microphone and obviously the speaker. So if you're not getting any TX audio and you're not getting any receive audio, it could simply be just that. So let's start with the speaker. So we'll get the board out. There looks to be 1, 2, 3 screws, and we can take it all out. Now I will just show you this, what I noticed, which is a bit of a strange design. That the metal clasp pin for the hand strap sits very close to the antenna there. Whether it can actually touch it, I'm not sure. It looks like it could do, possibly. And the factory on the other radio have fitted some tape around there to stop that from happening. And on this one, it's actually been removed. So I will actually put some Captain tape around that. It looks like what they've used. I'll do that once I've got it all working. But both antennas, I have to say, are absolutely straight as a die. And that is a real deal breaker on these radios when you get these. So if you're looking at vintage sets, always ask the seller if both radios are fully straight and fully there, and that no sections are pulling out, because that can really be a bit of a deal breaker. Right, let's take it apart. Okay, so it's highly unusual in that it uses both a speaker as an earpiece and a separate speaker simply as a microphone. That's all that speaker is used for. I've checked on the other radio that the receive audio comes out of here, and then this is used for your transmit audio. These are both 8 ohm speakers according to this. So what we'll do first off is we'll just simply check the coils of these speakers with our meter. So let's just pop our meter down there to one side, pop the meter onto continuity, there we go, and let's measure across our speaker terminals for the microphone first, and we've got 7 ohms across there, which I'll just drag that over so you can see the meter. There we go. Just getting a slightly dodgy contact. 7 ohms. Then on the other speaker, which we just have to lift up this little flap under here for, like a little cloth flap on the top of it, and that one is showing there as 31 ohms. I'm definitely sure that's an 8 ohm speaker, so whether that's measuring something on the circuit in parallel with it. I think we'd have to unhook one of the wires off that just to check that, because it's got a couple of wires going off of it. Now it's showing open circuit. Let's just check the probes. There we go. Check again. Yeah, that's showing open circuit now, which is really strange. Okay, so we appear to have a bit of an anomaly on this speaker, and it could simply be something as simple as the wires have come out of the other side of it. But my suspicion is the coil is gone. on that speaker, because we should be getting a reading. So that's possibly where our receive is going. So what we can do is we can hook a speaker up to that and just do a quick test, because at least we can tick that one off as a quick repair, that it's the speaker that's our reason for the lack of receive. So let's just find another speaker and try that. Yeah, so we've got a little speaker hooked up. It's only a tiny one. We've got the Randy on the channel here. We've just clipped on the back of the dead speaker and 1 2 1 2. Okay, a lot of feedback there, but that is definitely working. So yeah, the main problem with receive on this, although there might be capacitor problems, the main problem is the fact that that speaker's gone. So we're going to have to see if we can find another speaker of a similar size to that to fit in there. This one is just a test speaker. It's way too small to really have in there. It's only great, they wouldn't sound great. So that could be fun, finding one of those. I might have one in an old walkie-talkie, an old broken set somewhere, possibly, but probably not. So we'll have to look around to see if we can get a replacement. Right, so as far as the transmit audio goes, we know our speaker coil is okay. And it's certainly, we've got a resistance across it anyway. And this signal for that comes through the cal switch, which is just down there. So it comes into the cal switch on the one side and is switched through on the other side. So we've got continuity through that switch, and it goes up to the main circuit board there, where that grey wire hits the circuit board. Now I need to then follow that grey wire from the circuit board, you can see just in there, and see what's the first component that hits. Of course, I think it might be prudent just to use the tone generator, just to pop a tone onto that speaker, just to make sure it is actually working, and it's not just representing a coil, but it is actually working as a speaker. So let's just get the signal generator going and stick a tone on that to make sure it's right. So we just got the function generator, the FY6900, out of shot there. We're just going to pop a 1 kHz tone onto the speaker so we can test that speaker's working or not. And we can take this away and try not to jig the camera around too much for you. Pop it on the other speaker, and you can hear that we've got nothing going on that one. So we know it's dead anyway, but I just thought I'd show you that. The signal generators are very good for doing that. You can, a small speaker like that, just set it up with a 1 kHz 5 volt sine wave, and it's great for testing speakers. Alright, I don't know if you can see, wait for the camera to steady. It's had a repair done at some point in the last 45, 46 years. We can see a link here going down from the PTT switch to there, and then we can see where our grey wire comes in. There's a link going off there, so there's PCB trackers lifted from there. So what I'm going to do is I don't normally like to do this, but I'm going to open the other walkie-talkie to see if I can see how it should be connected, because you cannot guarantee that the person that's attempted to make this repair has done it properly. So I am going to take the other walkie-talkie apart. I don't like to do that. The reason being is when you do them one at a time, you've got a reference from the other one. If you take them both apart and strip them down together, then you lose your reference. But it's not so bad if you're doing what I do and you're filming it as you go. So you've got that photographic reference, of course. And there was some horrible gungy tape on the back side of this board, which has left a rather sticky mess on the back of the PCB, so I'm trying to avoid touching that because it's leaving an almighty horrible sticky mess on my hand. So what we'll do, we'll take the other one apart, and I'm going to just do a quick sketch just to see how it all goes and take some pictures, and then we'll remake that connection there and see if that brings our TX audio in. And then if it does, it's just a simple case of alignment after that, hopefully, and replacing that speaker. And once I've aligned one, I'll align them to each other, and they should work nicely as a pair then. Okay, so the problem we've got is, and you'll find this on a lot of walkie-talkies, the repair is okay, it ties up with the other one, but the contact inside the switch isn't making, so when you push the PTT in, the audio from the speaker isn't going back through into the radio. That's the problem. I've checked all the other contacts on here. They're normally closed in pairs, so when you see them in these arrays, you'll find these three are one set of contacts, these three are another, the other three down there are another set, and these are set, and the center pin is the changeover. Okay, so when you push the PTT in, these two will short, these two will short. When you release it, these two will short and these two will short. That's how it works. So the center is your common, if you like. The problem is it's not making on this side. What I will do, I'll try cleaning the switch first with some switch cleaner and work that in there to see if that fixes the problem. And there isn't any spare contacts I can use on the switch for this. The next step would be to take it out and just take the switch apart and to try and clean it. I've done that before, that does work. And in the absence of any other switches of that type, that would be the only possible repair option. And considering that it's already been hacked at, where it's been had a repair, I'm not so sure how well it's going to survive that kind of abuse. A little bit of solder there in the corner. So I'm not sure what the best option is. We'll try cleaning it. I want to try and avoid taking the switch off. If I have to, I have to. It's possible I could get another switch. It might be very similar to ones that are in the that's in a certain type of microphone, possibly a CB microphone. But I'd have to rummage around. But yeah, it's unfortunate. But they do take a lot of abuse. You know, those PTT buttons, if you over squeeze them, they can only take so much. There's some big heavy-handed person been using these possibly, and there we go, hence the damage. So let's see what we can do anyway. Okay, I've given that a clean. Let's pop our probes on to the switch. There we go. And we're getting a resistance of 0 ohms. So it's looking like we're good. So that was just a switch clean. I will clean the other switch regardless. I've given the switch a good clean and a good workaround. So let's see if we've got our TX audio back. I'm thinking that's hopefully that's all that is. The capacitors don't look too distressed on the main board, so if I don't have to replace those, I won't. Perhaps I will take one of them out just to see and test it, and if I think they're worthy of a recap, then we can just recap them. There's not many on there, is there? Let's count 1, 2, 3. There's only 3 capacitors on there, isn't there? So I think we'd be daft not to change them, wouldn't we? So let me just test the TX audio first on this, and then I think we'll do a full capacitor change, and then I'll go online, see if I can find a speaker. That's probably going to be the trickiest part of this whole exercise. And here's the President Randy in shot. Let's get my hand round here. There we go. As you can see, a quick TX on there. Don't stress too much on these 9-volt sets about having the antenna fully extended for quick tests. You will do no damage at all as long as you're quick. Just a lot of people, I'm more concerned about damaging that antenna by having that extended when I'm testing it than I am of blowing anything up in there that I can fix anyway, so we won't worry about that. So just thought I'd mention that. On the bigger radios, on the 4-watt radios, you must obviously have a load on there, but don't stress too much on these 9-volt ones. You won't. You have to be incredibly unlucky to blow the RF output and transistor on those with a 9-volt battery. So right, we know that that's okay then. So the lack of TX audio is simply that dirty switch, and we now need to go and hunt for a speaker. But I do want to, I'll go and hunt for that first so we can get that on order, and then we'll look at putting this one on the test equipment so we can see how on frequency each of those channels are. There doesn't look to be any adjustment for those on here, so I think we're gonna kind of be stuck with what we've got. I can't see that there's any adjustment on there, so there we go. There certainly won't be any separate adjustment anyway for these, but as long as they're within 300-400 kilohertz. No, joking. As long as they're within at least a kilohertz, I think that's as good as we could expect on these old things. But let's see what they do. Right, let's try and get that speaker. I'll take some measurements and then we'll come back, pop this on the test gear. Right, we'll move on to this radio and we'll take it, spin it over and check for bad joints on the PCB. But first off, we're going to clean the switch here and then we're going to change these capacitors. I'll test the old ones coming out. There's only 3 capacitors I can see there that need changing, so it's absolutely crazy not to change those regardless, isn't it? So let's do that first. So the first capacitor I've tested, Mr. Wang, he certainly was a Wang, wasn't he? His capacitor is a no part, so that's absolutely no good. So let's get a 50 microfarad capacitor and replace Mr. Wang's first capacitor. There we go, Mr. Chang in 2022 has got you beaten, Mr. Wang. 48 microfarads. That is as near as makes no difference, so that's going in. There we go, Mr. Chang. And Mr. Wang's capacitor, as you can see, is equally Wang. And it's taken its good time to test, and it should be 5 microfarads and it's 20. There we go. And during manufacture, what they did to stop these parts shorting out on the back side of the PCB was they put some horrible plastic tape on the back of the board, and it's absolutely getting everywhere. I'm having to stop and ungunge my hands every 5 minutes. So what I've done is I have a piece of old plastic. I've cut a piece of plastic that will just sit over the top of there, in air around the screws like that. Then we can just lay the board over the top and we're not going to have any problems with anything shorting out. Right, so this is radio radio B. This is the one without the bad speaker. So we've done all the capacitors, it's all back together, it's all been switched clean. You can see we've got white noise now. We've got proper white noise on the radio, and you can hear we've got the tone from the Tiny SA going in on our first channel, which is channel 14. Now the channel to set this on should be really channel 11, because that's in the middle of the 3. So that's what I'm going to do. I'm going to set this on channel 11. So on channel 14, so we'll put it on 270850 for channel 11, and then we'll do the setup from there. So we've got the Synada set on millivolts. So what we're going to do, we've got the maximum signal from the we've got a minus 47 dBm signal, which is coming through there, and on that volume setting there, it's giving us just over 12. What we're going to do, I'm going to set it for 12, and then we're going to adjust the signal now on the radio for maximum output. So I'm going to turn the audio down in the mix on this just because it's really loud, and we'll just go through those 3 inductors on the board to see if we can, because we need to listen to it to make sure it sounds good as well. We don't just want to just tune it to the Synad meter. There's our first one. That's kind of peaked really. Let's try the next one. That's a bit better. It's obviously drifted off frequency a little bit over the years. So this is the opposite of what we would see on a normal Synad reading. We want to be going to the right. We're looking for an increase in signal here, not a decrease. There we go. It's pretty much on though. That's not bad at all. Assuming we're on frequency. Right, that's receive done. I don't think there's anything else we can do on receive. I will just check. We've got one more inductor. Right, so in terms of microvolts, this is it listening to a 100 microvolt signal equivalent there. So that's about on par for the normal sort of AM walkie talkies. They're never going to be as sensitive obviously as a radio. So let's see how far down we can hear it until. So we'll keep tapping away on the Tiny SA until we drop down, until we can't hear it anymore. I'd say that's about your limit there. You can still hear it if I turn the tone, turn it on and off. There you go, you can hear it there. And that is at minus 83 dBm, which is 15.9 microvolts. So in terms of radios, of AM sets, of what you consider good, it's pretty deaf, very deaf. But you know, you're not going to get that level of performance out of these radios. It just isn't going to happen, is it? they're cheap walkie-talkies, very simple walkie-talkies, and all really that they're meant to do is to communicate with the other walkie-talkie. So yes, that for a 9 volt, for such a simple circuit, that is about par for the course, I'm afraid. But I think out in the field these will work probably better than you think. So I suppose we better look at seeing what kind of power it's doing. I don't think we're going to be able to get any meaningful power out of this through the power meter, but we could certainly try that. Yeah, and then we need to look at the transmitted audio. For that we'll look on the SDR quickly, but hopefully the other radio will align exactly the same, and then we can do a test with Tyler over the fields and just see how far we can get with these. But I'm really pleased that they're never going to be world beaters, but if you can get them back into the land of the living, get them working, hear that white noise, get a tone going through them, that's the best you can do. These are lovely radios. I've not seen these before, so yeah, these are worth saving. And there we go, and we can key up through the Tiny SA now. So we're now keying up back through the Tiny SA, and it's slightly off frequency, 27.0847 on there. It's slightly low. I've got it down about the same on the SDR on the computer as well. But we've got that, and we should have we should be able to see our modulation. One, two. I can certainly see that on the computer. It's a little bit low on modulation, but a lot of these walkie-talkies are unfortunately when they use the speaker as a microphone. But we'll see how that works out in the field. As you can see on the power meter, we've just put it through the power meter. We're only getting ever such a slight deflection there. So really low powered these, in the sort of probably 50 milliwatt kind of range, maybe 100 milliwatts if you are lucky. But that meter is not barely registering them in terms of power. So yeah, you're not going to be setting the world on fire with these, of course. But then again, they were never meant to set the world on fire. These are low power walkie-talkies completely. So yes, it'll be interesting to see how they do out in the field. They'll probably compare with some of the other radios like the Bosches you've seen on the channel, some of those other 9 volt AM sets. But interesting that they've got the 3 channels. But on receive, I think they're not too bad on receive. I think if there's any American stations around, we might well pick those up as well while we're out in the field. Yeah, so all of these inductors are really stiff, and I've mentioned on the channel before, if you're going to damage these by turning them, I can't turn them with the ceramic tool, and I'm not going to put a metal tool in there. They're very tight. And what I'm going to do is I'm going to check the other radio, and if the other radio is close, then I'm going to leave those. I'm not going to touch them, because I could very easily damage a core by touching these and trying to over adjust them. And for what? For another 50 yards of range maybe. So as long as the other radios tie up frequency wise and tie up on receive in terms of sensitivity, then that's good enough. That's the best we can do. So now I've got to just put these radios to one side and wait for that speaker to come. Hopefully it'll only be a couple of days, but once that speaker's here, then I can finish off the setup on that radio, and we can pop outside with them and try them out, and then get them back to Dom, who's been waiting very patiently for these, and it's been a bit of a backlog. So hopefully we can get them back to him and he can try them out for himself and have fun with them.